All right, ladies and gentlemen, welcome to today's chemistry class. And today, what we're going to do is we're going to review a little bit of the structure of the atom. So, today's class is kind of like a little bit of a history class with a little bit of science because we are going to talk about certain dates. So, in the video before this one, prior to this one, we talked about the development of the atomic theory. And pretty much we said that the atomic theory, the modern atomic theory, was first devised by John Dalton and Dalton, who was an English school teacher, pretty much said that the atom was indivisible. In fact, the definition of atom at that time was indivisible. It was later concluded that atoms could in fact be subdivided, and we know the basic parts of the atoms: the protons, the electrons, and the neutrons. And we're going to talk about those very briefly in this next video. But let's define, based on the fact that an atom does in fact have sub particles. Let's give a modern definition of the atom, ladies and gentlemen. And the modern definition of the atom is that it is the smallest particle of an element. So we can say an atom is the smallest particle of an element that retains the chemical properties. The chemical properties. Let's misspelled that. That maintain the chemical properties of an element or of that element. So basically, that is the modern definition of the atom, right? And I say modern, but it's pretty old. It's just modern when you compare it to the way Dalton had originally defined the atom. So an atom is basically that part that helps an element maintain its properties. And atoms are composed of protons, electrons, and neutrons. And real quick, ladies and gentlemen, atoms are composed of protons, electrons, and neutrons. And we're going to talk a little bit about the I'm sorry. We're going to talk about the discovery of sorts. So the first thing that we're going to talk about is cathode rays and electrons. So basically, the electron wasn't discovered until the late 1800s. Um, Let me write that down. Wasn't discovered until the late 1800s. Weren't discovered until the late 1800s. And of course, after Dalton, and just as most experiments or most discoveries in this era, it was purely or mainly accidental. Now I'm going to very briefly summarize the experiment, and pretty much, if you want the details, you can go into the pages of the book. This is, I believe, on page 67, if I'm not mistaken, 68, around there. But basically, what happened was that current was investigate or yeah, I'm sorry, investigators noticed that when current was passed through a um, or through a tube, the surface opposite the cathode blue. So basically, they had a test tube and they passed these cathode rays, and they realized that as they passed those cathode rays, the opposite surface of the tube began to glow. So they noticed, or that they hypothesized, I'm sorry, that the glow was caused by a stream of particles, which they called cathode rays. So they hypothesized. Give me 1 second, guys. Trying to get myself acclimated with some of these pages, and I apologize. Hypothesize included. Scientists thought that what caused the glow 1 second, ladies and gentlemen. The hypothesis that, or what caused the glow, or give me 1 second. Hypothesize that the glow was caused by what they called cathode rays. So basically, they noticed that when they pass electricity through a certain tube, it caused the opposite side of that tube to glow, and they concluded, or they hypothesized, that that ray had to be called a cathode ray. So no clear yet cut, um we haven't really gotten to what a cathode ray is, but this experiment was very important because it generated two very important things. um Basically, it says that the ray traveled from the cathode to the anode. So basically, it traveled from a negative to a positive side, right? Although they didn't know that that was a positive side at that point. um it says that the experiments revealed the following observations. Okay, so let me move this and let's really talk about real quick the observations. So this experiment revealed two observations, okay? The experiment revealed two observations. Two observations. One, the first observation that was revealed was that cathode rays were deflected by a magnetic field. By a magnetic field in the same manner a wire carrying electricity current. In the same way, a wire carrying electric current, which was known to have a negative charge. A negative charge. And the second observation was that the rays were deflected away from a negatively charged object. The rays were deflected away from a negatively charged object. Okay, so real quick to summarize this, is that the cathode rays and electrons. So basically, the atom was later discovered to be divisible, and we have protons, electrons, and neutrons. And the way that the electron was discovered was through cathode rays. And it says that the electron wasn't really discovered until the late 1800s. And basically, what happens is that investigators noticed that when current was passed through a tube, the surface opposite the cathode glowed. And scientists hypothesized that the glow was caused by what they called cathode rays. And two very important conclusions came from this experiment. Number one is that the cathode rays were deflected by a magnetic field in the same way or similar way that a wire carrying electrical current was deflected. And basically, they knew that the wire had a negative charge, so they tried to maybe assume that that was what was happening here. The other thing that was discovered is that the rays were deflected away from a negatively charged object. So pretty much they discovered in this experiment almost purely accidental the electron. Now we're going to see a little bit more details of that. And if we look on, we're going to talk about what else that happened. And this led to this what did this experiment lead to the discovery of? This experiment led to the discovery that cathode rays were in fact negatively charged. So they know that cathode ray was negatively charged, and um, that's one of the conclusions. I'm sorry. That's one of the many conclusions. So it's almost purely accidental that they discovered the electron, right? They realized that cathode rays must have a negatively charged particle. And in 1897, 1897, um, sorry guys, here it is. It says in 1897, English physicist Joseph John Thomson, physicist Joseph John Thomson was able to measure the ratio of the charge. Was able to measure the ratio of the charge of the cathode rays of cathode rays particle to the mass. Okay. And basically, Thomson concluded that cathode rays must be composed of, he concluded that cathode rays were basically composed of electrons. He concluded that cathode rays must be composed, and I'm just reading from the book, for those that are, had some issues, internet issues with the class today. So you can at least see what was in the book and hopefully highlight it. It says Thomson concluded that all cathode rays must be composed of identical negatively charged particles. Negatively charged particles, which were named electrons. So basically, although the cathode experiment or electrons was concluded, and basically they had an idea that that meant that cathode rays were composed of electron. It wasn't until 1897 when Joseph John Thomson actually was able to measure the charge. So what he did was he basically said, "Yep, you guys were right, and it's true because I can prove it in this manner." All right. So now let's talk real quick about the charge and mass of the electron. Okay, so let's talk about the charge and mass of the electron. Charge and mass of the electron, guys. And there's a lot of information here, but basically, um, it was concluded that electrons are present in atoms of all elements. So, of all elements. And it also revealed that electrons have a very large charge to mass ratio. Have a very large charge to mass ratio. Basically, what that means is that the more electrons, or the larger the amount of electrons present in an atom, the more electronegative it will be. Although we will talk about that in the next chapter. And we're going to talk about real quick about Robert A. Milliken. So, who was Robert A. Milliken and what did he do? Okay, so again, this is more of a history class to an extent, but this information is very important because it led to the discovery of a lot of things that today have been very helpful. And Robert Millikan, basically in 1909, measured The charge of the electron. Measure the charge of the electron and this discovery, along with the charge to mass ratio, led scientists to determine that the mass of the electron that the mass of the electron is about 1/2000th, 1/2000th. That's what basically means 1/2000, 1/2000th the mass of the simplest type of hydrogen atom. And based on this, two other inferences were made. Okay, and basically, uh, give me 1 second. Two other inferences were made. One is that because atoms are um, electrically neutral, are electrically neutral, they must contain a positive charge to balance it out. And let me move this here real quick, guys. So hopefully I'll have some more space. Um, and the second conclusion based on this was, and let's see if I can move this a little bit over here. And the second conclusion was that because the elect the electron was so small, they must contain other particles. So basically, they said, okay, one, there has to be a positive charge. Two, besides the positive charge, there has to be some other type of particles to make up the rest of the mass because the electron is not really that large. And they were right. And now we're going to talk real quick or try to summarize how the positive charge of the electrons were discovered. Okay. So basically, in 1911, and let me right here. In 1911, Rutherford Geiger, one sec, guys. Geiger and Marsden provided more detail of the atom structures. So basically, what they did was they bombarded the experiment that they concluded. And I'm going to type it up real quick. It says they bombarded a piece of gold foil with fast moving particles. They called alpha particles. Alpha particles. These particles were positively charged. And pretty much what happened, or they hypothesize that the particles would go through the gold foil. However, the alpha particles were deflected at a certain degree. So basically, they bombarded these particles, this gold foil, with a bunch of fast moving particles, which were alpha particles, which are pretty much positive. So, what they thought was going to happen, and let's see if I can illustrate it to you guys, was here's the foil, the foil. Give me 1 second. See if I can change that color again. Give me 1 sec, guys. I realize that I made a mistake. Let's change that, hopefully, to. So basically, what they did, and I just realized that I changed the. All right. So basically, what they did, guys, was they bombarded, and I apologize for this, but hopefully you guys can see it better. Let me try to illustrate what happens. So basically, you have this piece of gold foil, and you know, and I'm going to try to color it gold in a minute, or yellow because it's the closest color I have. Now assume this is all gold, and now they bombarded this with a bunch of fast moving particles that they called alpha particles. So we'll use black. So basically, you know what? Yeah. Let's see if I can make this a little bit artistic. They use red. I'm gonna draw them in red, and they bombarded. And basically, they thought, well, pretty much these particles are going to go through because the electron is so small that it's not really going to cause much change. Now, what happened was that they noticed that at a certain angle, when they hit these the gold foil at certain regions, the alpha particles would actually be deflected. So basically, they hit the particles, and as they hit the particles, what happens is instead of going through, they actually deflected and bounced off. And this shocked them because this was not what they were expecting. And this, of course, led to other conclusions that we're going to talk about right now. So I'm just summarizing the experiment for you guys. Basically, they bombarded these particles, and they pretty much expected the alpha particles to pass through, which they did. However, they realized that at certain angle, the alpha particles were deflected, and basically what he did was he reasoned that the deflection of the art of alpha particles must have experienced some powerful force. So let me go ahead and Rutherford reasoned, because Rutherford was the person who mainly did the experiment. The other two were his assistants or students. Reasoned that Rutherford reasoned that the deflection must have been caused by a densely packed bundle of matter with a positive electric charge. With a positive electric charge. And what he had discovered was that the volume of a nucleus was very small compared with the total volume of an atom. He discovered that the volume of the nucleus was very small compared to the volume of the atom. So basically, he discovered that the atom not only had electrons, but that there must be protons, and that they were tightly packed, and that basically the nucleus, which was pretty much what he concluded, he found was very small and compared to the rest of the atom or the rest of the volume of the atom. All right. So again, it was Rutherford in 1911 who basically, if we want to summarize that in its simplest form, he discovered the protons, or that they were positively charged. So let's then go ahead to some other very important conclusions based on of the structure of the atoms that have helped us give us an understanding of certain things that have been occurring. And basically, um, we know that all atomic nuclei are made up of two particles, are made of two kinds of particles, two kinds of particles, a proton, which has a positively charged particle, a proton, and a neutron. And that is because, and a proton and a neutron is electrically neutral because it has the same amount of protons and the same amount of electrons. Okay. Now, um, again, has um, atoms are electrically, neutral because they have the same amount of protons and electrons. So, what do we know about protons, electrons, and neutrons? Well, real quick, some information that I'm going to give you is that a proton has a mass of 1.673 times 10 to the power of 1.673 times 10 to the power of negative 27 kilograms. And a neutron has a mass of 1.675 times 10 to the power of, I'm sorry, to the power of negative 27 kilograms. And slightly larger than a proton. Slightly larger than a proton. And one very important thing is that the nuclei of atoms of different elements differ in their number of protons. Okay. So basically, a proton has a mass of 1.673 times 10 to the power negative 27 kilograms. A neutron has a mass of 1.675 times 10 to the power of negative 27 kilograms, slightly larger than a proton, and that the nuclei of atoms actually differ in the amount of protons that they have. So that's what basically helps distinguish one element from the other. Real quick, how do they or there are forces in the nucleus that help maintain stability. So forces in the nuclei and basically one thing that helps maintain stability is pretty much um, when protons are extremely close to each other, there is a strong attraction between them. So that actually helps maintain stability. And pretty much the short range neutron proton interaction and the short range proton proton interaction are referred to as nuclear forces. So basically, one of the things that we don't understand or don't really take into account is we assume that protons are not closely bounded together, but they do. They do, and that's actually what gives them the stability. Give me 1 second, guys. We're almost done here. Hopefully, um, give me 1 second, ladies and gentlemen. I apologize for the technical glitches. All right, so we talked about the mass of the proton. We talked about nuclear forces. We talked about what basically helps them stay afloat. And the last thing that we need to talk about is the radius of an atom. So let's talk real quick about the radius of an atom. And let me just move this over here. And how can we define the radius of an atom? So basically, the radius of an atom is the distance is the distance from the center of the nucleus to the outer portion to the outer portion of the element cloud of the electron cloud. I'm sorry. Of the electron cloud. It says because atomic radii are so small, they are expressed basically. Atomic radii is so small that it is expressed in picometers. Remember, we're talking about subatomic particles, and the atomic radii, which is basically the distance of the center of the nucleus to the outer portion of the electron. That distance is so small that it has to be measured in a unit called picometers. So pretty much one last thing to conclude is that these are not the only subatomic particles. There are other subatomic particles, but the importance of these subatomic particles, specifically protons, electrons, and neutrons, is because they are or they help maintain certain chemical properties or characteristics of elements. So these are not the only subatomic particles, but these are the ones that are mostly studied because they help maintain the property of the element. So guys, hopefully this video will be of use to you. And so stay safe and we'll see each other in our next class. Bye.